Welcome back. This is the fifth video in the first unit, which is limits and continuity. This is also the last video of this unit. So this particular video is about infinite limits. Let's begin by our first strategy here, which is making a table. If you have a function such as this, where f of x is equal to 3 over x minus 2, and you're having trouble finding the limit as x approaches 2 for this, because you see that it makes the bottom 0, and if you have an image of it, you can see that the graph kind of looks like that. It's really weird, but most likely you will not have an image. So our best strategy here is to make a table. Plug in these values like this into the function and see what it gives you. As you can see here, the function approaches completely different values from both ends of 2. At 1.999, it's about negative 3,000, but at 2.001, it's positive 3,000. This means that the values that are being approached from both sides are completely different, and therefore, this limit does not exist. Here's some stuff about vertical asymptotes. If you have a function like this, where f of x equals x over 2x plus 1, x plus 5, first of all, make sure that there's no factors on the top and the bottom that match, because then you can cancel those out. Make sure to factor everything down, and then cancel any factors on the top and the bottom that are the same. If you can cancel a factor, that factor is a hole in the function, and that is called a removable discontinuity. Now, whatever makes the bottom 0 after you cancel everything, that would be a vertical asymptote, which is a non-removable discontinuity. That is the difference between those two. So in this case, x equals 1/2 and x equals negative 5 are both vertical asymptotes and also non-removable discontinuities. Here's some stuff about horizontal asymptotes. Basically, you just set the limit as x approaches infinity of f of x, and L would give you the horizontal asymptote if there is one. And finally, this is how you take the limits at infinity when you're trying to find a horizontal asymptote. There are basically three main ways. If the degree of the top is greater than the degree on the bottom, degree is basically just the greatest power that an x is raised to on the top or the bottom, or whatever letter it is. It could be any letter, but whatever the greatest number that it's raised to is. So here you see that the top is 5 is the greatest, and the bottom 4 is the greatest. So if the top is greater, then it's infinity. If the bottom is greater, then it typically will be 0. Now, if the powers are the same, you take the coefficient next to the greatest degree and you make it into a fraction. So no matter what else is being added on the top or bottom, you just keep the coefficients of the two with the greatest degree. And if that degree is the same, then you do this. So that becomes 3/2 for this case. Thank you.